All right, well, we can go ahead and get started. I think we'll probably have a couple more people coming in, but tonight we have 3, possibly a 4th alumni with us who are currently at Aerojet. So I'm going to have each of them introduce themselves, tell you their job title, and what they did on, well, ARA, Ares, and yeah, and then they can go into, oh, there's Brett. And then they can go into individually what they're doing at Aerojet. So Baker, I see you first. Do you want to go ahead and start?
Yeah, sure. So I at Alabama, I was with Ares for 2 years before ARA kind of became the leading organization, I guess you could call it. So I was on Ares 2 and Ares 3. Ares 2, I did primarily the composite design, or not composite design, composite building work with Britton. So that was a good time. And then on Ares 3, I did primarily CAD support, doing the CAD design on the big copper motor that's in the lab. So
awesome. All right.
All right. I'll go next. So my name's Karson Holmes. Some of you probably know me because I'm only about a year out. So I graduated from Alabama in 2019 with Master's in Aerospace Engineering and an MBA. Did my mechanical undergrad there as well, where I was involved with ARA and Ares. I was the program manager on Ares 2 and Ares 3, and kind of helped. I know some people call it the founding of ARA. I consider it more of a reboot because it existed, right? But it was much smaller and it kind of exploded. So was there kind of at the ground level of that and helped some of that growth. And stayed involved. I was the president of ARA during my grad school year and before I left. And now I'm working in design engineering in Huntsville at Aerojet Rocketdyne, doing controllable solid rocket motors, which we'll kind of talk about a little bit more a little bit later. That's what I got.
All right, Britton.
Yeah, so I'm Britton Reynolds. I graduated with all 3 of these other guys here. I started back with ARA and Ares back junior year doing Ares 2. Like Baker said, I worked with him on the composite design or the composite tubes for our rocket. Going into the senior year, I was moved over to doing some of the liquid engine stuff. So working on chamber design and doing the initial performance analysis for the engine. Also at Alabama, I was in CBH, which is now RRS, and I did some undergraduate research with Dr. Baker and Dr. Olshman with that program. So I'm up in Huntsville working in the mission architecture department at Aerojet on the space side of things. So I think Karson and Baker are both working defense side of stuff. Brett and I are on the space side. And so that's mainly, kind of concept analysis, concept development kind of stuff. Yeah, I think that's all I got for right now.
All right. And then Brett, just a short intro.
Okay. So I'm Brett Austin, like these guys said, graduated in 2018 from undergrad. Let's see. So I was involved with ARA and the reboot, as I call it too. And then Ares as well, like the engineering manager, I think, for Ares 2 and 3, when we got the liquid stuff started. And then now I'm a design engineer in West Palm Beach at Aerojet Rocketdyne as well. Like Britton was saying, space side, but I'll talk more about that in a minute.
All right, sweet. So if you guys want to go in the same order or whatever order for your presentations, we can go ahead and get started.
Don't worry, I got it.
All right, take it away.
So, all right, so we already kind of covered the introduction, so I'll skip some of that. So as I mentioned earlier, so I'm in design engineering and controllable solid rocket motors in Huntsville. I actually interned with Aerojet in the summer of 2018 after my senior year. And so, and Britton hit on this as well, that controllable solid systems are primarily used to support our business or defense business unit. There are a lot of space applications as well, but most of what we do is defense, and most of the space is more kind of heritage stuff. Sorry, the video is in the corner of my screen. So I wanted to kind of provide an overview. I'll kind of start with the note that everything on the screen is publicly available. On the defense side, we get pretty touchy about what we can share and what we can't, obviously for good reason. So all of this stuff is actually from research papers that you can go out and track down yourself. So just as an FYI. So Aerojet Rocketdyne as a whole has an extensive history in controllable solid rockets, and kind of the main point of a controllable solid is providing the flexibility of a liquid with the reliability of a solid. And it's really key for certain applications, the biggest one being missile defense, where you're launching from a ship, so liquids get a little bit sketchier. So you move to a solid because it's considered safer, because you don't have to worry about cryogenics and things like that. The other application is roll control systems, because solids give you a really small packaging. So you can package a small roll control system, but you can still use throttling solids to provide more dynamic and flexibility, right? So looking at some of the pictures, the main kind of concept behind it, you can see in the upper right. Essentially, you're using a pennel, moving it in and out of the throat to control your throat area. So a larger throat area obviously gives you a lower chamber pressure, which slows your burn rate, lowers thrust. As you move the pennel closer to the throat, you decrease your throat area to raise your chamber pressure and increase burn rate and thrust. And some of the benefits of it is kind of highlighted in the bottom left. So if you take a standard missile, which is this one's representing the Hawk program, you add a controllable solid aspect to it, and you get the benefit of being able to go further and higher, right? Because you're able to throttle down when you don't need the high thrust. And same kind of thing, looking at the left side, just showing kind of the basic components as well. You're using an electromechanical actuator to move a pennel in and out of the throat. If you can see my cursor, right, you have a pennel that's connected to this with a shaft to this actuator back here, moving it left, right, with hot gas coming in from the side. Well, yeah, we'll do questions later. And so to hit on the primary application, right, I hit missile defense is the biggest application. And in that application, we have what we call a TDAX, which is a throttleable divert and attitude control system, so this one's shown on the screen. The picture on the left is an SM-3 missile, one of Aerojet's biggest, it's one of our biggest missile defense programs. And the top part of that is a kill vehicle, and TDAX would go on that kill vehicle, which is the interceptor. And as you can see here, there's actually four thrusters that are your divert thrusters, and then there's 6 ACS thrusters on this far end. So it's all controlled off a single solid motor gas generator located in the middle, right? So that is all I got as kind of a precursor to what controllable solids are. And so then we'll do questions when we open up to the forum.
Good.
Okay. Okay. All right, y'all. So we covered all this info. We talked to you about, so our specific, the one unique thing about me here, we've got a bunch of overlapping, design and space versus defense and then all that. But the one unique thing here is I work it down in Florida in the West Palm Beach site, where we were originally Pratt & Whitney. And Pratt & Whitney, who you may know for making jet engine, usually, they randomly decided when they were diving headfirst into hydrogen and oxygen, they decided to make a rocket engine. And they made the RL-10. It's an upper stage rocket engine. They just, on this whim to make a rocket engine, happened to make the highest performing rocket engine still today, I think, at least upper stage, biprop, certainly the highest performing there. And so through a bunch of acquisitions and whatnot, the portion of Pratt & Whitney at this site that does the RL-10 and does a few other things got sold and eventually became a part of Aerojet Rocketdyne. Some neat things about our sites, we've got both the sea level and vacuum test stands, or multiple of each actually on site. So that's pretty cool. And of course, if you're going to do the design and development and then also the testing, well, we've got the in-between, the manufacturing and assembly as well, where we manufacture parts as well as assemble the RL-10. We also assemble the RS-25 and RS-68 turbopumps. And then we've also got palm trees and wild boar. If you take the 5-mile single lane road out to the test stand, you see some interesting things, wild boar, alligators, all that kind of stuff. So it's an interesting place to be beyond just the rocket engine stuff. So I mentioned the sea level test stand. That's what you'll see here on this video in the top right. This is actually one of our development in RL10 programs. It's the RL10CX, where we're taking, this is one of the RL10s here in the bottom right. We're taking that steel tubular chamber and we're replacing it with an additively manufactured copper one. Just as Karson said, this information, same thing, is all publicly available. So don't get too excited. I'm not divulging any secrets or anything, but it is exciting stuff. And of course, the feature of that new design, which you could put together, is that it's a shorter chamber than the steel tubular one. So we are able to test it outside instead of in our vacuum test stands. The steel tubular chamber goes out to such a big nozzle that it would be overexpanded to be run at sea level. So you get separation along the walls and be all kinds of bad stuff. So it's a neat thing about CX that we get to test it outside and quickly and rapidly go through iterations. Other programs we do at this site, we do some hypersonics. We do a little defense stuff. Of course, can't tell you about that stuff. It's in our secret room, secret clearance stuff. But also I don't know any of it yet because I haven't started working on it. I'll be starting in about a month when RL10CX wraps up. We also do a little bit of RS-25 overflows. When our LA site does most of the RS-25, or formerly the Space Shuttle main engine, we'll do a little bit of that and help with some of that work as well, getting it ready for SLS, just like that model of the RL-10 that's pictured there. In a more kind of broad scope, but at the same time more specific, the design process. So the way the design discipline works is we are focused on producing drawings, right? As we go through a process where we're given requirements to create a design, things like material requirements. I'm going to be designing a part that goes into space on the RL-10, right? So you can't have something that's going to off gas, or you of course you've got structural requirements. So it needs to be so thick and so strong and all that. And so you get these requirements, and then you have to, in design, put that together and create something that'll meet all those requirements and do the function that it's supposed to. That's a pretty neat opportunity though, because we get to kind of sample into those other worlds. You get to go into structures and talk structure shop with them and learn about what they're doing. But day in and day out, I don't have to, go run the structures models and look at the pretty colors and that be all I do. I think design's kind of a sweet spot that gets us to have fun and all around. And it includes even in the whole life cycle of your product, right? So with every design, you should be going and talking to manufacturing and assembly to make sure that, although your theoretical design may meet your structures and aerothermal requirements and all that, that's great. But if they can't make it, or they hate building it, that's going to be quite a problem, in the big picture. So it's kind of neat that we get to be involved with not only the theoretical design up front, but the reality of putting it together at the end too. And then of course, to bring it back around to the design, the way our site's a little bit unique in that my job is to do the design. So I take the requirements input and funnel that down into an actual design and pass that along to our product definition group, who actually makes the drawings and puts together the artwork that is those drawings. Now, how ARA got me here. So the most applicable, I would think, to you guys. First of all, of course, where else are you going to learn about rockets on Alabama's campus? If you're interested in space and rockets, EcoCar will teach you a lot of good, engineering skills and whatnot. But if you're really wanting to know about rockets and get involved with that, that's where you're going to do it, right? And so that isn't necessary to then go on and have a career in rockets. I mean, most people don't get that opportunity, especially when you talk to people who've been working for 30 plus years. There weren't rocket programs at every school. But it does give you a leg up. My first day as an intern, I walk in and my mentor takes me over to a mock-up RL-10, starts showing me what this mess of tubes and pumps and wires means. And I was able to pick it up very quickly because I knew how a rocket engine worked. And Also because an expander cycle engine is much simpler to understand than like the stage combustion, SSME and all that stuff. That would be pretty brutal, but the RL10 is pretty simple to figure out, especially since getting involved with ARA and understanding rockets and how they worked. Of course, stuff that, you know, you're going to be told the key skills you're going to get from being involved with programs like this. First is the kind of the empowering idea that you can figure it out. It's okay if you don't know everything. Being an ARA, I would assume most of you haven't, you know, launched high-powered rockets before being involved in this. Maybe not even launched any rocket at all. There's a lot to learn, and so getting comfortable with the idea that you don't know everything is, like I said, really empowering. And really, from what I've found, that seems to be all that an employer, especially for a, you know, straight out of college hire, is that's what they're looking for, is just that you are comfortable and able to learn. And ARA will definitely push you through that. Teamwork as well, it's right into the same thing. So, you know, you may not know everything. Somebody else may know something that you don't. Being able to work with people and being comfortable to express what you do know, what you don't know, and being able to cooperate with folks. Of course, that's integral to working in the real world. No way in the world I could do the full design by myself. You know, I just don't know the depth of structures knowledge or materials knowledge that other people do. So being able to interface with those people and work towards that common goal of getting our drawings released, it's huge. And of course, ARA pushed in that direction. And then public speaking, which you're going to hear about everywhere, is a good skill to have. But the thing that I think is interesting about it is we always think of speaking to a room of 20 plus people is public speaking. Doing I've done presentations in front of, for CDR reviews or PDR reviews in front of multiple customers and people WebExed in, the room packed. And that's your typical, like, oh, that's scary, right? Definitely, but it can almost be just as terrifying, if not more, to walk into a room of 4 people who really know what they're talking about. And ARA and ARES and all that will definitely put you in those situations, you know, because you should be going to reach out to those people who do know what they're talking about and can help you. And so getting comfortable with, again, kind of expressing what you do and what you don't know and being willing to learn. It's all great skills that ARA taught me and has helped me in my short career so far. Last 2 points: experiences fill an interview. Just all the stuff that we did with ARA, all the little projects, and then the side things, the challenges, and what we did to overcome them. Both of my interviews with Aerojet Rocketdyne, I started actually as an intern and then went on to full time. They weren't question and answer interviews. They were fun conversations. We just started nerding out about rockets. They looked at the resume and said, oh, that's pretty cool. I see this. And of course they pointed to something about ARA or ARES, and we just went off, nerding out about, you know, stuff that they did at work and what I knew about it from experiences with ARA and ARES. And it made the interview much more pleasant. And ultimately, I think, you know, they end up just finding out, okay, this is somebody who, you know, likes what we do and gets what we do, and also could be, you know, fun to have around at work. It's a often overlooked aspect, is enjoying who you're with, and that rolls into the work can be fun. That's one of the major reasons why I picked where I decided to settle and go to work here, is the people were fun and everybody liked what they were doing. And that's, you know, you join ARA and ARES thinking, okay, you know, this is an extracurricular, it's something I'm interested in, it should be fun. And that can roll straight into work. You know, it's just no different for me. And hopefully you'll find the same thing when you go into the workforce, that the fun that you have doing these extracurriculars and programs can be the same thing day in and day out with work. So that is how ARA got me to here. Now let's see if I can figure out how to stop sharing. Bam.
Awesome, thank you. All right, next I'm gonna share Britton's PowerPoint. Okay. And just tell me when to go to the next slide.
Yeah, sounds good. All right, yeah, so like I introduced myself before, but my name is Britton Reynolds. You can go ahead and go to the next slide. Yeah, so I started back in Alabama in 2014 and graduated in 2018 with a bachelor's in aerospace. I'm currently pursuing my master's at Purdue University in aeronautics and astronautics. I started just about a year ago with that, and since it is online, 100% online, I'm taking my time with it in conjunction with work, and so I'm going to, right now I'm set to graduate in late 2022. My concentration with that is astrodynamics and space applications, and then I've also got kind of like a sub-concentration, which is aerospace systems, and those two things kind of go hand in hand with the work that I'm doing, so that's kind of the reason that I chose those two areas. But yeah, like I said in the introduction, I was a member of ARA for 2 years at Alabama, my last 2 years. I came in with Ares 3, or Ares 2 junior year, and then continued on with Ares 3 for the senior design team. Like I also said, I did CBH and RRS now for the 4 years I was at Alabama. I did some research projects under Dr. Baker and Dr. Olshman, working different projects. I think one was a design of a radiator, doing some CAD work and 3D printing, and the one with Dr. Olshman was more performance prediction for solid motors. And then I'm currently living in Huntsville, which I think I also said that before. So we covered the introduction and background fairly quick at the beginning. All right, next slide. So I did intern with Aerojet back in the summer of 2017 in the mission architecture group up in Huntsville. When I came into that group, the company was still, at least the Huntsville presence was still about 65 people. That has drastically changed now. We're up, I think the latest estimates were almost 450 people in our main headquarters in Huntsville, in Research Park, with almost 100 other folks in our manufacturing plant up north Huntsville. So the site has changed drastically since I first came in as an intern in 2017. The work that I did was primarily focused in two areas, both a little bit on the space and a little bit on the defense side. For the space side, I did Earth to Mars kind of trajectory and mission design. And the defense side, I did worked on some solid motor killed vehicle ballistics, which is pretty close to. I actually worked with one of the guys that Karson works with pretty closely now. And something I wanted to touch on this is getting the internship, which eventually led to my full-time position. Really boiled down to the research experience I had with the professors, and then the project team experience I had with ARA and Ares. And I think any of the guys that got internships and eventually full-time jobs can attest to that. Having the project experience, that extracurricular experience, really plays out in the end. And so yeah, after graduation, I returned to Aerojet in the summer of 2018, working in that same group, but I focused on the advanced space concept side of things. And so we've got, I think, all three of the other guys here talking. They work in the design engineering side. That is, the ground floor, the people that are going in and actually doing the design, making things work, figuring things out at a hardware level and individual component level. That the company sees, whether that's some kind of a quick analysis that's being done for a business development or a strategy person in the upper levels of the company, or you're going forward and you're trying to put a proposal in to win some contract that then is going to, you're going to go in and actually get into development of an engine or whatever subsystem you're looking at. So yeah, we work directly with the business development and strategy leaders of the company, and with the primary goal of gaining new business and garnering interest, as well as kind of influencing what new technologies the industry is going to undertake. So that could either be working with customers such as NASA or DoD, trying to influence what they're going to do in the future. So yeah, next slide. So like I said at the beginning, I work more on the space side of things. In the past 2.5 years since I got back to Aerojet, I've worked to support several NASA and DoD, as well as some internal development programs. I've got 3 images here on the side that, again, were all pulled from AIAA papers and stuff like that, so it's all public. But these are the 3, probably the biggest projects that I've worked on as far as the past couple of years have gone. So one, you've got the nuclear thermal propulsion. That's a pretty big contract, pretty big program that's run by NASA Marshall. That's the vehicle you see there on this on the far right of the screen with the kind of gold mylar strapped around it. And so that's, you know, human class and cargo missions from Earth to Mars, trying to go in the mid-2030s. Something else that we've worked on more recently is human class lunar landers, which you can see an image of that as well, directly supporting NASA and the Artemis program, which then they made several awards to some different contractors. And some of the other side of stuff is some in-space solar electric propulsion transfer vehicles, looking at, you know, dropping off in some kind of an Earth orbit, and then using your EP thrusters, which are low thrust, high efficiency, in order to raise that orbit to get to your destination. So that's something that's going to take a lot longer than your normal, you know, kind of a Hohmann transfer trying to get from Earth orbit out to the moon. So instead of it being, you know, I think Apollo was 3 or 4 days, this is going to take almost a year. So obviously it's not going to be a crewed mission, but it's going to be some kind of a robotic mission where you can deal with the extra transfer time, but you need to have a smaller launch vehicle or less propellant, or you have some other requirements that require you to go towards an electric propulsion solution. Something else that's pretty unique for our group, we don't get to touch a lot of physical hardware much. So our day-to-day work really involves kind of high-level analysis for space missions. This is the really top-level kind of stuff, back-of-the-envelope analysis. So some of that can be some of your mission or trajectory design or trajectory analysis. And it can also be kind of vehicle concept definition. So trying to figure out, you know, how much thrust you need for a specific vehicle, whether that's an upper stage of a rocket or a launch vehicle, or if that's a satellite that's doing some kind of a propulsive maneuver, as well as, you know, some of the SEP stuff as well. So that's kind of, you know, how everything plays out. It's a wide-ranging kind of a top-level stuff. And like I said before, the group handles both stuff on the space and defense side. The defense side is more focused on missile defense, as well as maybe your large booster or tactical stuff, which some of these other guys really they can you know, speak to more than I can. But this kind of stuff, you know, goes on company wide. It's not just specific to the space side. And so yeah, I don't think I have any slides past this one. Yeah, there we go.
Awesome, thank you. All right, now I will pull up Baker's. Oh.
All right. So as we kind of already talked about, my name is Alex Baker. I also work at Aerojet Rocketdyne, considering that's kind of the theme of this talk. A little bit of background on myself. I have my Bachelor's of Science in Mechanical, graduated in 2018. During school, I worked at co-op. I didn't have an internship at AR like these other guys did. So that co-op was my kind of valuable hands-on learning experience. And that was in automotive industrial automation. So not really related to what I do now, but I was also working that job as a kind of design engineer role. It kind of got me the I guess fever for design engineering. Realized that's really where I wanted to be, what I wanted to do. So that was a good outcome of that experience. I was also a member of the ARA/ARES groups for 2 years. I came in with ARES 2, like I said, working composites. And then ARES 3 worked on CAD support and kind of just general design work. Also, like Britton was saying, I'm also from Alabama. I've been here for 15 years, and I've lived in Huntsville for 2 of those. So next chart, please. So I got full-time employment at Aerojet Rocketdyne right after I graduated in 2018. I was hired into the composite design group as an associate design engineer, and I primarily do work for the defense business unit. So next chart. So of course, because of ITAR as well as other restrictions, I can't really talk about a lot of the stuff I do as far as program specifics. But all of these, with the exception of our good friend Kim Jong-un in the bottom right corner, are all Aerojet products, and they're all publicly available pictures, so I'm not breaking any rules here. But my job, to kind of bring things full circle. So Britton was talking about how his group kind of takes the big picture look at things, and plans the missions. And Brett was talking earlier about how we as design engineers design to requirements that we're given. And so a lot of the times those requirements are kind of figured out, if you will, at Britton's level, and then his group will flow those down to us, or they go through an intermediate stage where those requirements are further derived out to get us more designable details there. But you can kind of start to see a picture of how all of this comes together. And so just a couple of little points about pictures on the screen there. So on the left side, that's an Atlas V. The solid rocket booster on that is the AJ-60A. And I've been blessed, I guess you could say, to work with the gentleman that designed the case on that. He was one of my mentors for a while there. So awesome work experience there. In the middle is a motor for the Air Force, which is actually, I believe, the same motor you're seeing on the upper right-hand corner. So in the upper right-hand corner, you're seeing it on the winder in our Sacramento facility before it was closed out. And then it went through some extra processing after that picture, and there you see it firing on the test stand. And then the bottom right picture was just a little bit of fun there. It was something I saw a while back. It was a picture of Kim Jong-un with a motor, and I noticed it was filament wound motor, and I thought that was kind of interesting. But next chart. So these are just a couple pictures from my time at Alabama, which actually, just to wrap things up about me, it's kind of a funny story about how I got into composites. I never really knew much about composites, didn't have any strong interest necessarily. Started working on the Ares 2 team in the composites group. And so you can see that picture on the right was the first composite tube that we wound in Dr. Roy's lab. And that was a super proud moment for us. It took us 6 hours to get that thing off the mandrel. And we eventually had to freeze it off. Just kind of an interesting little story. You can see the same tube there in the middle. And then on the far left there, that picture is that tube as part of the rocket. And so that composites experience, actually, I think in a way kind of wound up getting me the job that I'm in at Aerojet, because I kind of put on my resume, hey, I did composites work, and at the time Aerojet was looking for composite design engineers. And so it's kind of these, I guess, funny things in life that happen to bring you to where you are, that I've kind of enjoyed the path there. So I was really happy and proud with the work that we did on Ares 2. I'm just sad that we never got that rocket back. I put a lot of blood and sweat and tears into that thing, and we did get one good video of it flying though, so at least we got that. But that's about it for me. So.
All right, thank you guys so much. So does anyone have any questions? They can be for everyone or people specifically, and you're welcome to send them in the chat as well.
I think I have a question that everyone might want to know. Pretty Googleable, but what locations does Aerojet have offices at? And other than Huntsville and West Palm, what do they kind of do there?
Yeah, I guess I can speak to part of it, and other people may have input as well. So there's kind of 5 main engineering sites for Aerojet. You have Redmond, Washington, which is in-space propulsion. You have Los Angeles, California, which is our their primary program is RS-25, but they do liquid. Holy crap, Liam, your beard. Sorry, Los Angeles does primarily liquid propulsion, large-scale liquids, and then they also do defense work, which for upper stage DACs, liquid DACs. You have Huntsville, which is our defense headquarters, which does, as stated, primarily defense work. But then we also have a large mission architecture group here, as well as electronics supporting SSME due to partnership with NASA here in Huntsville. As Brett hit on, West Palm, hypersonics, RL-10, supporting both defense and space. And then last but not least, Orange, Virginia, which has some engineering support, but it is primarily a manufacturing facility. And I guess on that manufacturing note, we also have Camden, Arkansas, which has minor engineering support, but it's also one of our large manufacturing facilities for the Defense Business Unit.
Thanks.
I'll ask a question. So kind of now that you guys have seen how the industry does big projects and stuff like that, what ideas would you have to improve the way that ARA does projects?
Pay your people.
Besides those
Get rid
that
of papers.
money.
Just do everything in PowerPoint.
PowerPoint PDF.
You know,
Honestly,
yeah, you know, they tell you that all of your presentations, you're going to have these long papers, and maybe some of the space programs do, but all of your big design reviews are all normally done just via chart package. And it may be not the 80 charts. Maybe you're talking about, I think the last one I did was over 500.
yeah.
But it's much more effective at conveying content and without all the fluff, right? Because I can speak to our experience on Ares, right? The content was really easy. The stuff that you wanted to convey, you knew. But then it was all the other extra research to fill it in with fluff to hit a page limit that was set, right? So there's a huge benefit of kind of cutting out the stuff that doesn't matter and conveying the point to actually convey your design, convey your project, right? Would be the biggest recommendation I see.
There would be so that recommendation absolutely solid. Cut out the crap that, you know, is just a school requirement that isn't going to be effective in training you really for work. But there's a walking the line of cutting out the fluff, but maintaining, and I'm thinking relative to Dr. Branham's senior design approach. So he's doing that from his industry experience. And I mean, it's really funny to look at what we do on the, you know, the RL-10 programs and compare it to, you know, what he was trying to do with our senior. I mean, he was actually copying what he and the Air Force did with these kind of programs. It's a great idea theoretically, but to cut out the crap, but still maintain some of that structure of having to go through and develop, develop your top level requirements, flow those down to more attainable requirements, and then create your design. But, you know, to contain that a little bit, he at least while we were there in his senior design, it seemed not quite structured for, you know, you to be able to achieve that in a year. But the idea is fantastic because it's totally what we do. But it'd be nice, yeah, if there's a little more structure on the front end to kind of give you a place to start and then build out your requirements and that kind of thing. That's a really hard thing to ask, but I want to make it clear that we really do follow that process. It's just finding a way to make it attainable within a reasonable time.
Yeah, and I think I'll add one more point there, that the other part of it that you see a lot in industry that at least we didn't do while we were there is, right, that we were always waiting till the next gate review really and waiting to put content in that. But there's so many intermediate steps that it's important to get stakeholder input, right, to go to people that know what they're talking about and say, hey, are we making the right choice here? So what you often find is that when you get to those gate reviews, it's just a collection of stuff you've already put together, and you're combining it to present it like a CDR or a PDR. But you've already gotten this input to guide those decisions, so you're not shocked when you get to a big review, right? In that process, we call them ERBs at Aerojet, right? Engineering Review Boards. But that can apply directly to what you're doing on campus too, right? Going and having smaller meetings, smaller reviews to kind of get feedback on what you're doing early rather than getting shocked.
Mm-hmm.
Yeah, and to add to both of those statements, and specifically what Karson was talking about with ERBs, the source of those ERBs are trade studies, and that is a hugely important part of what we do. Whether we're trading materials, so just a theoretical example, you want to build a metallic motor case, you have a couple options that are easily accessible. You have aluminum and you have steel. And so from your requirements, you can say, hey, we need to hit so many feet. And you'll do the calculation, your ballistics calculation, to say, hey, the rocket needs to have this much energy, this much momentum, or whatever the inputs may be there. But then you need to go and see, okay, well, given that, and now we know how our motor needs to perform, if we build this case out of steel, my wall thickness will be blank, and that much steel will weigh so on and so forth. And then you do the same thing for the aluminum. So you're basically doing two lightweight designs for two motors side by side. You're not flushing them out fully. You're not adding all the details, but you're getting a general close enough type picture of both of them. And then from there, you can down select and say, hey, we now know that the aluminum option is best. It's going to have thicker wall. We're going to lose a bit of propellant, but it winds up that it trades out better just due to like a mass ratio or something like that. So definitely trade studies are hugely important.
Yeah, and I can kind of talk to that. With what we end up doing in mission architecture, running trades is kind of our daily life. That's something, even if we're looking at something as simple as like a structural material or a specific configuration, and whether that's an engine that you're trading different engine thrust levels or whatever, that's going to define your requirements that then you're going to flow down to actually do your design. And so probably the best thing that you can do at the beginning, you hear it sometimes with professors. I've heard professors say it. I've heard engineers say it. Garbage in, garbage out. So if you run a trade study at the beginning and you're throwing in information that's not has the most accuracy, it's not founded in the right stuff, then you may get a design all the way down and realize, oh, this is gonna break, or which is fine. I mean, and then you're gonna take that lesson and then you're gonna apply it to the next iteration. But that can be, spread, wide throughout the design cycle, whether that's, your initial requirements, derivation, or if that's your testing down at the very end, cradle to grave kind of stuff. So yeah, that's something that I've learned in the last few years that I wish I knew going in.
Okay, that's all super helpful. Thank you. All right, anyone else have a question? I can keep asking questions, but I think we prefer some other people's interests.
I ask a question.
Yay.
So it seems that you guys got into Aerojet by getting internships. So what do you think the best way to get an internship at Aerojet is?
Well, I would say go to the career fair. But seeing as now that looks quite different, it can be a little bit more difficult. So when I got mine, I literally just applied, which that kind of sounds like, oh, you didn't go talk to anybody, but Aerojet wasn't recruiting at Alabama when I got my internship. So I literally just I think I went to Google and put in like rocket engineering or something like that, and it just so happens that Aerojet's website is rocket.com. So that's, I think that was maybe like a targeted ad at the top or something like that, or a sponsored ad or something that popped up at the top. So that's how I found the website, and I just found something that I was interested in and applied. That's not going to be, every situation. Talking to these people, making connections at career fairs is a big thing. I know Space Day still goes on. Even this year, it's going to be virtual. but that's a big way that you can, kind of can make personal connections when you can get in and actually talk to these people, because sometimes it can be a little bit more difficult. But if you actually get in and you're passionate about what you're talking about, especially if this company works on that, and you can really show that, hey, I'm interested in this stuff, and I'd be a good fit. So that is one area I would definitely say to look at.
Yeah, and from experience wise, right? What Aerojet's looking for is the type of stuff you're doing, right? You're involved in organizations like ARA, like Ares, where you're going out and doing design teams. I think all of us will say that this design team and this program was a big part of why we are where we are, right? Aerojet recruits heavily at Alabama. They've worked heavily with this program, ARA, Ares, in the past, right? And so making those connections, using this organization to its fullest, right? Especially like events like these, coming and talking to employees that are there now. That's all playing a role in where you could end up. So take advantage of every opportunity, right? Go talk to people when you can. Britton hit on Space Days, that's coming up, and Aerojet's going to have a big presence there. So go talk to those people, make those connections, and just get your foot in the door. And then obviously Alabama is one of our big schools that we target. So just applying helps too, right? You can shotgun it on our website and do so because we have a ton of opportunities for internships and full-time. And Alabama is a school that Aerojet likes. So
I was going to speak to the shotgunning. I was going to say, don't be afraid to, particularly in the disciplines. I mean, we just told you a little bit about what design is and what mission architecture is, and some of it may sound appealing, but you don't really know what that job is like, and you can't until you do it. And an internship is a great trial run, and both you and the employer, or Aerojet Rocketdyne specifically, will see it that way. From what I've seen, even if you go into a group that you're not crazy about, but you get in and you spend your summer there and learn about how the company works and what kind of stuff they do, you can also spend that time, and Aerojet Rocketdyne specifically tries to get you to learn about other disciplines, because they get that you're not necessarily, aware what you want to do. So spend that time learning about others, and then it's my experience that people want to hire the people they're already comfortable with. Aerojet Rocketdyne, once you've got that internship, even if you want to jump to another group, they're much more likely to take that kind of person. Then, it's understandable that it's a risk to hire somebody outright that they haven't had experience with, versus someone they've had as an intern before. So, even if you're not really sold that structures is where you want to be, or that, CP, component product engineering is where you want to be, wherever, it's okay to spend a summer trying it out and learn about the others while you're there.
Yeah, and Brett he mentioned a good point there. If you're coming as an intern and Aerojet does a good job of getting you kind of exposed to different groups, whether that's through, other engineers that your group works with, or by, going and actually listening to some of the other sites. We'll do presentations throughout the summer on what kind of work goes on there. Maybe you may hear a specific group that does a specific kind of work that you're interested in. If there's an availability there and that people, are interested in you, you can always make a jump. I think a couple of years ago, an intern in my group actually interned the next summer and was in Brett's group. And so that ended up happening, as well as, we've had interns, which will be in one group in one summer at a specific location and say, hey, I like that job, but I really would like to go out here and try this. And they were able to kind of jump over and look at another group, even if it was a different site completely. But that's happened several times. So that's always an option too. And kind of speaks itself to the shotgun effect, if you want to call it that.
And I'll just throw in there, from I'm the one guy here who didn't have the Aerojet Rocketdyne internship. But go get, if you don't get an Aerojet internship, go get work experience somewhere else. If you think you still want to do this when you get out of school, go work anywhere. Just try to figure out what you enjoy doing. So for like I was talking about earlier, like I after my internship or co-op, I knew I didn't want to work in automotive. That was one good thing it taught me, is I'm not built for that. But I really enjoyed design. And so go get that experience at least, and keep showing that, that you like doing rocket stuff too. Keep working with ARA, really put your soul into it. Just kind of, just show that that's what you enjoy doing, because at the end of the day, that's what a lot of the managers really look for, is somebody who is going to enjoy what they work on. So.
Thank you for your answers. I'll take them into consideration.
We have a question that someone submitted to me early. So what would you guys recommend learning now that would be useful in your career later? Whether that's something you learned from ARA or something you didn't and you wish you did?
I wish that we had listened our senior year to Alex when he came back raving about drawings, and he was our, he was our go-to guy on CAD and drawings, because he had just done this work experience where he learned how, he liked design and all that. It's crazy how much of my day ends up, I end up answering simple little questions for people who they don't know how to read a drawing very well. So they end up asking us, who are forced to learn it. And in school, unless you seek it out, beyond what is it Engineering 160 or some class like that, where you do drawings for one semester and then think, man, I'll probably never touch this stuff again. And honestly, the level that it got to wasn't even really that helpful. Seeking out, incorporating that into the projects that is great, and getting experience in them can really give you a leg up, I would think. Walking in and not feeling like, what is this complicated mess that I'm looking at? To be able to understand that no matter what role you go into can be helpful.
Yeah, and carrying on with that, as far as drawings go, something I didn't even know about when I was doing this. I mean, when I was doing drawings at Alabama, it was just plus minus dimensioning. I kind of knew about fits, as far as sliding fits or interference fits and all that stuff. But one thing that I've gotten exposed to in the aerospace industry that was a slap in the face, kind of a cold awakening, is GD&T. So geometric dimensioning and tolerancing, it's a whole nother language, talking about how do you control your tolerances. And so that's something that I'd advise if you are like me and you knew that you wanted to do design engineering, and you might have that CAD experience doing the 3D modeling, start working stuff you model, make a drawing for it, go learn GD&T at least at the basic level, so you kind of get an idea. And if you put GD&T on like resume saying, hey, I've learned how to do this, that is huge coming into a position, because the first 2 months I was working at Aerojet, I was looking at drawings, I was like, what? And know about it. So definitely look into that.
Yeah, I'll give a related but not the same. The other thing that I wish I'd done more of at Alabama was getting into the machine shop and actually learning how things are manufactured, right? There's a lot of things that we do in the industry, right, that you come up with a design and somebody looks at you and goes, how are you going to make that, right? And you sit there and you go, oh, that's a good point. It's it doesn't really make a lot of sense. So there's a huge push right now, and additive manufacturing is helping some of it, rethinking the way you design things, but traditional manufacturing is still king in the aerospace industry. And Alabama, I don't think it does a good enough job in the mechanical engineering curriculum to teach this stuff. And by that definition, I would think it doesn't do a good job in aerospace curriculum to teach how things are manufactured, right? So getting your hands-on experience with ARA and other teams in the machine shop, going in and doing things yourselves, or if you're having the professional machine shop do it, getting in there and actually learning what they're doing, why they're doing it, all of that is extremely important. And when you're designing things on the front end, go talk to those guys. Go say, hey, if I did it this way, is it going to make it harder for you to make it? Or what if we did this instead? Or get their inputs on your designs, because they're going to have things that are extremely important on little features that you would never think of without getting their input. Things as simple as the number of setups something has to take in a machine, right? The amount of time that it takes for somebody to take a part out of the machine, reset it up into a lathe or into a mill, right? That's time, that's money in the real world. And for you, it's time for sure, because at least when we were there, the professional machine shop wasn't fast. And I would assume they're even getting busier. So you have to think about that. And so anything you can do to speed up those turnarounds and get manufacturing input, and doing that early, so when you hit industry, you have some idea of how that works, because it's extremely beneficial from a design perspective.
Yeah, absolutely. And that feeds back to the GD&T thing. GD&T on its own is just symbols on a page. So until you understand, hey, I'm telling a guy I have to hit a 1,000th positional tolerance on a part that's 3 feet large, and he looks at you and goes, how in the heck do you expect me to do this? It's not even going to work with like thermal expansion. Like if you machine this thing in a room that's 70 degrees and you take it to a room that's 80 degrees, by the time you get it there, you're out of tolerance. So stuff like that. You have to take all of these things into account. And that's a lot of, this is us kind of harping, I think, from a design engineering perspective, because this is all stuff that we didn't know, that we do now. This is just general experience, is that you kind of have to learn to take these things into account in your design process.
Head Liam.
Okay. I was going to say, based on that, keep in mind, Jane and I participate in Dr. Paul's engineering leadership class. We offer those workshops, and we do teach machining. And I'm pretty sure almost everyone here has not ever signed up for it. So now you have something to look forward to. But I did have a question for Britton. Britton, can you talk a little bit about, your experience continuing your education while working from a personal level, and then, all of you guys can talk about, I guess, from an Aerojet level?
Yeah. So I can go in depth a little bit. So one of the nice things that Aerojet has, and this is going to be, any company or most companies out there have something where it's a kind of a tuition reimbursement program. So Aerojet definitely has that, and that is something that I would say, take full advantage of that kind of a thing. But yeah, so going directly to school, I decided to kind of take a year off, and just kind of sit back and really sink my teeth into work for about a year, and then I kind of decided, well, I'm ready to kind of get back into school. I want to get my master's out of the way while I'm still somewhat fresh out of undergrad. I don't want to take too much time off, because then it's just going to be so much harder to get back in to the mindset of doing homework and taking tests. And so I decided to do Purdue, just because the nature of the work that I do, they kind of tend to be the ones that are driving a lot of that, with the trajectory analysis, as well as some of the your kind of systems analysis, linking models together, which is something that I've been working at a lot lately. So yeah, as far as working, day-to-day life, I've had some classes where I would get done with work at 4:30. I would walk downstairs, grab something to eat, walk back up, and do homework for 5 hours. That was absolutely, I will just be honest, it was miserable. But it was a difficult class that I had to take. I actually took it with Chase. And so he was able to, we enjoyed pain together, trying to get that class done. But it's one of those things where, you get done with work. If your class is something that, or if you're taking, your focus is something that you work in a lot with your job, that can be a big benefit, because you're going to turn around and not only are you going to be able to apply lessons learned in your job to that class you're taking at that moment, but then you can, reverse that role. And if you find something out in the class and say, oh, hey, I didn't know that, or, this is a little bit more in depth than I got in undergrad, that can help, kind of influence what you're doing at work. Yeah, time management's a big thing. You want to, not overload yourself too much, because you do have a full-time job, and then on top of that, trying to take at least 1 or 2 classes. which can be difficult. Yeah, I know a lot of people do it. I think there's a few people in Carson's group that have done the online masters while working. There's several in my group that have done it, so it is 100% doable. And a lot of people end up going in and doing that. I even think people will get their PhDs while working, which I would never do that. But I've definitely seen people tackle that head on, and a lot of times they'll kind of combine their PhD thesis with what they're working on. But yeah, I don't know if that answers your question, or if you're looking for anything specific.
No, definitely, that was great.
Yeah, I'm gonna add one note to the education thing too. So if you go into work and maybe you're not ready to go do that full master's program, one of the cool things that Aerojet has offered in the past, right, is you can go do these short courses at things like MIT's online, where the design group offered everybody that they'd pay for it if we wanted to go take a design for additive manufacturing class. So and little things like that. It was a 12-week course where it was completely online. You could go learn more about how to implement additive manufacturing in your daily job, right? So for people that aren't ready to dive into that full master's or aren't ready to commit to a 3-year program, Aerojet's still very supportive of going and continuing your education in other ways, not just through company-sponsored programs, but also outside at university classes and things like that.
I had another question for Britton. You said you worked in like mission architecture and analysis. Could you kind of go through what, like, I guess a day at your job is like? Like, are you given a project every week? Are you having to work like on the same problem for like months at a time? Or is it like a day-to-day, look at this and then get back to us kind of thing?
That's a pretty good question. So it's a little bit of both. So that program that we've worked on, the nuclear thermal propulsion. So that program is now in its 4th year. It has, kind of evolved from what it was when we were first starting, which I wasn't even with the company. That was 2016 was when that first started. And so the work that they were doing at that point, we're no longer doing that. We've kind of evolved the design and evolved, and the contract or the program itself has evolved. But yeah, so as far as day to day, we can get questions like someone, some person is going to talk to a customer or go and talk to the military, and they're going to have a meeting and they say, you know what, I want to have this analysis in my back pocket. In case a question gets asked, or in case somebody says, well, I heard so-and-so can do this. And, I want to either kind of refute something that someone is saying, or I want to kind of back up something that someone's saying. So they'll come in and say, hey, I need this analysis in like a week, or I need it in 2 days. Just do the best you can. Give me some kind of a number. And so that can be as simple as running the rocket equation, coming up with an ISP required or a delta V. And you're making an assumption on like a payload mass fraction or propellant mass fraction for either a satellite or an upper stage or a launch vehicle or something like that. So that would be kind of on the quicker side, where you're going to have like an hour or 2 hour turnaround, just answering as quick emails or someone walked up to your desk. You can extend that out to work that maybe takes place over a month or 6 weeks, where you're doing a little bit more detailed analysis. You're going to run several trade studies and look at, I go back to thrust level because that's one that gets thrown around a lot, but also different propellant combinations, or different ISP. If you're working with a electric EP thruster, you're gonna trade power level, because that's an integral part of the overall system. You'll trade power level, ISP, different things like that. That may be a little bit more in-depth analysis. It's going to take a month or 6 weeks, but in the end, you're gonna plop out either an answer, or maybe someone's wanting to understand, the trade space. They're gonna say like, I can pull up the lunar lander stuff. Aerojet is a propulsion company, and we were looking at full up lander system designs for NASA, and that was more about trying to understand the overall design space or the architecture space. What's the mission going to look like? What are the trade-offs versus having a 3-stage lunar lander versus a 2-stage lander? Are there going to be issues with launch vehicle availability, or is a certain system going to cost more than another one? So that would be an example of analysis that would take 6 months. That's going to be, even a higher level of fidelity. So yeah, it can either be stuff as quick as, an hour or two, or maybe half a day's work, up to things that, 6 months, and even, this one program, it takes 4 years. We're not doing the same work we did back then, but it's still, it's still the same fundamental problem of trying to figure out what this transfer vehicle is going to look like and what mission you're going to do.
All right, thank you.
Yeah, no problem.
That would Brett, Karson, or Alex, would you say you're, other than the type of work, obviously, but would you say, your days are kind of similar or pretty different on the, span of how long you're working on projects? Is it pretty rapid, that kind of aspect?
By the time it gets to design, it's typically a pretty fleshed out effort. We kind of know what to expect a little more so than probably the mission architecture guys, where like Britton was saying, something that could have been like a 2-day study winds up turning into something super long because interest was generated by that original study. But by the time it gets to us, we kind of know, hey, this program is going to have 1 year to do something. So 1 year to get to test, or 2 years to get to test, or something of that nature. And then we go and work from there. So.
Yeah, and I would say, yeah, it's definitely longer term in design. There's very few things that you're on for a day or a week, right? Sometimes you are asked to support proposal efforts or and things like that, where mission architecture, his group will come to you and say, hey, we need pictures to show for a proposal, right? Essentially, or some realism added to a design that they're working on the mission architecture side. And so the design supports that effort, but the primary role of design is to take those system requirements that are derived for actual programs and carry it through. So on a normal program, a design effort could be anywhere from 6 months for designers that out on working some of our liquid programs could be 20 years, right? There's because it can fall into production support as well. So it very much is, it can't be as short, but it can be much longer.
Yeah, and go ahead, Brett.
You're good, Britton. You're good. I'll transition.
Yeah, so Karson mentioned having mission architecture folks coming and saying, hey, I need some CAD. I can 100% guarantee that mission architecture is not a CAD job. Those real pretty pictures that you saw on a couple, I think the last chart of my little intro slides, were not done by us. There was some design engineer that said, I'm going to hack something together. So if you get really close, you may see parts not match up correctly. I am well versed in PowerPoint engineering, which is, I need something to look a specific way, and I have 2 pictures that kind of look like it. So I'm going to crop those pictures to make it look like another thing. So it is 2 different sides of the spectrum versus, real high level like PowerPoint mockery versus an actual CAD level design.
I don't know if we might be a little bit different than the design folks in Huntsville, or maybe specifically our managers is really interested in getting people experience around in different programs and different kind of tasks, to focus on the actual. You get assigned a task, particularly with components. You can get assigned, hey, we need this component designed. That kind of work could last for a couple months, maybe. It could be as short as, honestly, 1 month if it's a really simple thing. Then on the flip side, you can be a part of, I've been doing some components, but as well as the engine system level. And so I've been kind of orchestrating components that need to change and doing all that stuff. For a few years now. It's basically since I started full time in August of 2018. Has been system level of RL10CX, which has been a couple different engines. And so my actual assignment has been to do the engine assembly level. And then depending on which engine it's, you know, we're working on with component designers saying, okay, we need interfaces here at this place and, you know, this kind of thing. But so it can definitely range. And yeah, of course, the walk-up questions, preparing for a review, one of those 500 slide reviews where your section needs to be, you know, a chunk of that. Design ends up doing, you know, probably a third of the slides, you know, when you put together all the pictures that we create for everybody. It gets hard to get your own thing done. But yeah, so you can get, you know, little things that chop it up, but then you know, you can have kind of the medium tasks that rotate, you know, you get a different job every, you know, month, maybe a couple months long. And then, you know, if you want to, and your manager puts you there, you can be a part of a program for years and years. I mean, honestly, to Carson's point, you could be supporting production for decades. So yeah, it varies significantly.
Yeah, and I can, at least in Huntsville, one of the, and this happens at other sites too, like Baker and I can both attest in the design engineering, we're at any given time, we're supporting 3 to 4 different programs, right? So you're also playing a balancing role of trying to meet the task of one while that one's on fire, and then moving to the next one while that one's on fire, right? So it's, your day becomes very much a time management thing, just like Britton was hitting and relating to school, right? Your normal work day is a time management thing too, because you have a lot of people pulling you on you different directions. And it almost feels like you're back in school where you're trying to balance classes, trying to get stuff done, right? So it's one of those things that a lot of the skills you're learning in school for time management and getting work done, it's going to apply directly when you get into the work field too, because it's an incredibly important skill in a company, in a defense company.
There is a nice side to that, you know, if you've got multiple people coming to you saying, hey, I need something that's going to take a day and I need it in a day, you can look at one of them and say, sorry, yours is less important. That was hard to do with professors. It's a little bit, you know, easier. You can say, sorry, hey, I know you don't actually need it in a day. Because sometimes people, you know, just like professors, they ask for it in an unreasonable turnaround. And so there's a little more room to negotiate with people in the workforce.
All right, well, I know we went a little bit past 8 o'clock. If anyone has any other questions, you're welcome to stay on, but otherwise we can wrap this up. If any of you guys have to go, you're welcome to go, but thank you so much for hopping on. This was really great.
Yeah, thank you. It was fun.
Yeah, thank you for having us.
Yep, thanks. Yeah. Good afternoon.
Actually, a question, if that's all right.
No, Ben. No, Ben. You already got your turn.
All right, fair enough, Karson. I'll just weave in.
No, go for it.
What kind of community outreach does Aerojet Rocketdyne do?
So I would say the Aerojet Rocketdyne does have a big foundation where they support STEM outreach in general, and at different sites they do different things. But I like most big companies, most of their big community outreach is through donations to charitable organizations and to project teams and programs, right? So I know Aerojet Rocketdyne in Huntsville is a big supporter of Space Camp and things along those lines. The Aerojet in Sacramento does sponsors a big school program out there where they go work in classrooms and talk to students. So and I can speak to those because Huntsville people are Heritage Sacramento, right? So I know some of the stuff that went on out there, but I would say most of it becomes our foundation giving back, right? And then on site we do some general food drives, school supplies drives to support local charitable organizations, but not as much of a employees themselves going out into the community.
Yeah, our West Palm Beach site has one program where there's a couple individuals involved, and it's a small program too, so it's limited on how many people can get involved with it. And then there's another single day event, I think, that's kind of a STEM, not a STEM fair day, but it's kind of a big STEM competition. Multiple schools come together and do multiple competitions, and we send some people to support. Actually, one of the events I supported was a water bottle rocket competition they were holding. So there's a little bit of that, but yeah, I'm mostly what Karson was saying about, they are foundation.
Yeah, and I guess I'll throw in there, just in case we're just not aware. We're speaking to our own knowledge, right? So we're not saying Aerojet doesn't do it,
Right.
but it's not something we're aware of.
Yeah, thank you for the response.
One thing that I've noticed Aerojet does a pretty good job of compared to other companies, not that I have a ton of experience with other companies, is they have like a lot of emphasis on doing like out of work together activities. I kind of forget what like the program thing is called. I know in Huntsville Ryan's in charge of it, but like, can you talk a little bit about that? You know what I'm talking about?
Yeah, in Huntsville, so you mentioned Ryan Worse. He's the president of our launch organization, which every site in Aerojet has a launch group, which is focused on bringing people together outside of work and really building a community at their respective sites. So I think that your experience in Huntsville, we're still growing a lot, and that launch group is working on growing and building that community, because Huntsville itself is kind of a hodgepodge of our other sites, right? We brought a lot of people from Sacramento, a lot of people from Virginia. And so making that connection and bringing people together was a big part of what launch was meant for in Huntsville. At other sites, I can speak to LA a little bit from interaction with their launch leadership team. They do a ton of events. They do weekly happy hours when it's not COVID. They also are a big proponent of our lunch and learns, where they bring in people and speakers for enterprise-wide discussions on different topics. Since COVID hit, our launch groups have kind of shifted tunes, and they've been doing virtual happy hours where they're bringing in topics for speakers to come in and talk about kind of hobbies and things that they do in their free time. Some interesting ones for sure. Our Redmond site hosted one on how to grow tomatoes and things like that, right? But it's pretty cool, right? They really are focused on trying to build that community at each respective site, and then from there, those launch groups work together to try to build a community across the enterprise as well.
Ours is actually fairly small as well, and I think a big influence of that is as more folks in our generation join the workforce, they're a little more interested rather than the people with families and whatnot. But beyond that too, it seems like Aerojet Rocketdyne just kind of sponsors a culture that everybody's pretty friendly and engaging in general. I find myself, being, developing relationships with people that we would go and do things outside just naturally beyond the already structured events that AR tries to have everybody having access to. So.
Thanks. I know the Virginia site does a lot of happy hours too, because there's not much else to do in that area. But...
Yeah, you didn't get to experience it in Huntsville, Liam, since y'all are remote, but that's one of our big things that we do, and they're normally a pretty good event. So.
Yeah, I know Ryan. Last year, Ryan presented a lot about it, and I'm on a couple programs with him, so I kind of talk to him about that stuff every once in a while too.
All right. Any last questions? No. All right. Do you guys? Just one last thing. I think all four of you guys are in the Slack. If you guys ever want to reach out with questions, do you guys mind if I drop your emails in the Slack as well? If people want to reach out with questions.
Not at all.
All right.
Nope.
Sweet. Thank you so
That's
much.
fine. Hey, for the people that are still on, I threw it in the chat, but Britton was talking about a big lunar landing trade study. He'll actually be giving an hour-long presentation on that at Space Days next year in 2 weeks. And Aerojet also has another 3 presentations that they're bringing about various parts of the company. So attend those, enjoy those. And Aerojet should have a lot of good content there for y'all.
Awesome. Thank you so much. All right. Thanks, guys, for tuning in.